Hi guys. So here we're going to discuss about the first law of equation in the fluid flow. So as we have been discussing about the basics of fluid flows, we have said that the three laws which plays the base role. So one is law of conservation of energy, mass, and momentum. The first one we're going to discuss would be law of conservation of mass. So based on which we're going to derive the continuity equation. So we discussed about the concept of continuum, where we assume that the fluid is continuous, right? So the law of conservation of mass, it states that the mass of a fluid entering a control volume is equal to the mass of fluid leaving the control volume if no fluid is added or removed from the control volume. Okay, so if no fluid is added or removed, it's a very important statement. Then the mass remains the same. So let us consider we have a two cross section. So we have a pipe. So it's an inlet one and it's an outlet. So 1, 1, 2, 2. It's an the cross sectional area. So A1 is the area of cross sectional inlet. V1 is the velocity at inlet. Rho is the velocity density of a fluid at inlet. So similarly at A2, V2, rho 2 or velocity density at outlet. So here we're going to find out the mass flow rate. So mass flow rate at inlet. So mass flow rate. So it means that the mass which flows per second. So we call this a mass flow rate. Maybe kilogram per second, liters per second, or meter cube per second. So in the sense of 10 liters per second, you call this a mass flow rate. Or we say as a discharge. So when you open a tap, the water that comes out from the tap, you call it as a discharge. Even if you go for selecting a pump, you'll have some discharge. Per second it will throw 1000 meter cube per second, sorry, or 2000 liters per second. It depends. I'm not giving it exactly. It depends upon the motor specifications. Okay, so we call it as a discharge. So the other name of discharge you can say is a flow rate, mass flow rate. Okay, right. So this actually depends on density of fluid, area of cross section, and velocity. So the mass flow rate at inlet equal to rho 1 A1 into V1. Similarly, the mass flow rate at outlet equal to rho 2 A to V2. So by law of conservation of masses, the mass flow rate at inlet equal to mass flow rate at outlet. So rho 1 A1 V1 equal to rho 2 A to V2. So this is a continuity equation, basic continuity equation. If the fluid is incompressible, say for example it's the fluid that flows on a pipe is a water, it cannot be compressed. So the density remains same, right? So if you cannot compress, the density remains same, that we have discussed in different types of flows, compressible and incompressible flows. So density will not vary. So density remains same. So rho 1 will be equal to rho 2, or density 1 will be equal to density at the exit. So the continuity equation becomes A1 V1 equal to A to V2. So this is a basic continuity equation. Okay, thank you guys.